What if I wanted to measure the height of a statue, a tall building, or a beautiful tree? In this video, I'm going to show you how to make a tool that will help you do that. Today, we're going to make a DIY clinometer. Here's what you'll need. You'll need a paper, straw, tape, string, and some sort of weight. The first thing you need to do is create a 45, 45, 90 triangle. Here's an easy way to do it. Fold your paper like this. Try to get that corner lined up the best you can. So when you're done, it should look like this. You're gonna cut on that line. Okay, so when you're done, you should have this triangle right here, an isosceles right triangle. And what that means is that this side and this side are the same length. I like to staple it just to keep it a little more sturdy. So I'm gonna staple it. You could glue it, you could tape it. We have a couple other things. We have our plumb line. We have our straw. Let's put our straw on. So to put our straw on, we're going to tape the straw along the longest side of the triangle. So that way you get a nice, accurate reading. So now you'll see my straw lined up with this edge, and I left a little bit hanging off, and that's so that I can look through it, like that. Okay, now we have that part built. Now we need to tie our string to our weight. I'm gonna use this binder clip, but if you wanna use a paper clip, that works great as well. And the last step after we've made our plumb line is to then tape it to the top up here. And you want to do the same thing you did with the straw. You want to try to get it as close to that edge as you can. So when I tape it, you'll see that I'm trying to line it up with this outside edge here. So on one edge, the straw is hanging off, and on the other, we have our plumb line. So this is what it should look like at the end. Now that we've built our clinometer, let's go test it out. Before we actually go and measure something, I want to quickly talk about the math behind what's happening. We're trying to create a giant 45, 45, 90 triangle. Here's why. In a 45, 45, 90 degree triangle, the two sides that are not the hypotenuse are exactly equal in length. So here we see that x equals x. So if x equals 10 on the bottom side, then on the left side, x would also equal 10. We can use that knowledge to help us find the height of a tall structure. Imagine I wanted to measure this tree. If I can somehow create a 45, 45, 90 triangle between me, the base of the tree, and the top of the tree, then I can measure the distance between me and the tree, and it will tell me the height of the tree, because x equals x. So for example, if I measure the distance between me and the tree and discover that it's 50 feet, that tells me that the tree must also be 50 feet tall. We're trying to create a giant 45, 45, 90 degree triangle using a smaller one, the clinometer. Can we use our DIY clinometer to measure this monument? If I had to guess, I would say it's probably about 50 feet tall, but we don't have to guess. Let's measure it. If you remember, first I have to find the top of the structure in the straw. Keep that hypotenuse straight. And I found it, but my string is way out. So I've got to come closer. And as I come closer, I'm going to try and keep that top of the structure in the straw. And I'm going to stop here and take a look. I'm getting close, but I still need to go closer.
Take a couple more steps.
Let's take a look. The string is now touching the edge of the triangle, telling me that I am either too close or at the perfect spot. I actually think I need to back up a hair.
Okay, right here.
And yes, right there is perfect. The string is completely parallel with the edge of the triangle. Here's how I know that I had the right spot. When I was looking through the straw and I found the top of the structure, The same moment that I can see the top of the structure and this string is parallel with this edge of the triangle, I have found the right spot. Now the wind is blowing it a little bit, but let's see. Let's try it again. So if I'm looking right at the top of the structure, and the edge of this triangle is parallel with the string. So that's how you know you're in the right spot. And now that we have found the right spot, I have to measure the distance from the base of the monument to this spot. Now that we're back from measuring with our clinometer, let's talk about what happened. Here's the monument. The first time that I went to measure, I discovered that I was too far away from the monument. Here's how I knew. The weight on the clinometer was too far out in front, so that was not correct. Then I came closer, but I came too close. You'll see the weight is actually swung in the other direction on this clinometer. That also does not work. Then I backed up a little bit, and I found the sweet spot. I knew because the weight was hanging directly parallel with that outside edge. It was 9.5 meters away when I measured it. That's roughly 31 feet. 31 feet plus about 6 feet off the ground equals about 37 feet tall total. Here's a closer look at the math behind it. So once I found the sweet spot, I measured the distance between me and the monument, and it was 31 feet, which means that the monument's also 31 feet tall, but not exactly, because I have to also include my height. So the clinometer was roughly 6 feet off the ground, so 31 feet plus 6 feet equals 37 feet for the total height of the monument.